Since we have adopted a hands-on approach to training, it means that you will have to use a statistical software with real-life data sets to learn the concepts that we will illustrate. This requires us to pick a software for the courses, and I have picked SPSS. There are several reasons for my choice, but the most compelling reason is that SPSS is one of the easiest, if not the easiest, statistical software to learn. One may ask, from an argument's sake, why not use spreadsheets? Almost every computer is loaded with one, so why not use them for statistical analysis? I think spreadsheets are tremendously important and useful tools. I use spreadsheets on a daily basis, but not for statistical analysis. Spreadsheets are good for a whole variety of analytics, but not necessarily for statistical analysis, and the chances of making a mistake are much higher with spreadsheets than with tools designed specifically for statistical analysis. And it's not just the novices who would make mistakes with spreadsheets. Even the world's top economists have been known to have made mistakes with spreadsheets, resulting in embarrassing situations. With spreadsheets, you don't have reproducibility. You do an analysis with point-and-click environment, and there's nothing to trace back your steps if you were to find an error later. You will also have a restricted tool set. As statistics and analytics are discovering new modes and new methods every day, spreadsheets are pretty much confined to the basic tools that they introduced some 10-15 years ago, and that new tools have not been added at the same pace as they are being created. And then again, if you have a large data set, your odds of making a mistake increase with the size of the data set, because the very logistics of handling big data in spreadsheet environment creates opportunities for unintended mistakes. So how do you go and move beyond spreadsheets? You work with SPSS or a software that is designed for statistical analysis. You can work with big data or bigger data sets, and you would have at your disposal a comprehensive set of tools that are state-of-the-art and then are easily deployable. So methods like neural networks and logistic regression, which are not available in spreadsheets but are available in SPSS and other similar software. And in fact, a large amount of effort is dedicated just to data management and data cleaning, and then once the data are ready to be deployed for analytics, that analytical part takes less time and effort. The other more important element of using SPSS is your ability to reproduce your research using scripts. The point-and-click environment is complemented with scripting. That is, every command you execute will generate a script, and that script will be readily available to you at a later date if you were to reproduce your research. In a nutshell, SPSS is easy to use, easy to learn, has amazing data management and manipulation capabilities. It has a ready set of advanced statistical tools. It offers the flexibility to use either the point-and-click environment or to create a script of your analytics. It has tremendously powerful tabulation tools and reporting tools, and it has some state-of-the-art data visualization tools built into it. Let me illustrate with examples why a tool like SPSS is more suitable than spreadsheets, because we can do things with these tools that are not possible with spreadsheets. So going back to the same data set where we looked at 463 courses, let's generate some data visualizations to see why tools like SPSS are preferred. Here we are looking at a histogram that shows the distribution of teaching evaluation scores, which average around 4, and then you could see that some even had 5, but fewer people had 5. Most likely was the 4 was the most commonly awarded teaching evaluation, but there's a spread around it. This is something that you can do with this histogram you can generate with a spreadsheet as well. So how do you go beyond it? Let's have a look. In this example, we are looking at the same data, but now we have created 4 histograms. They are differentiated by gender, one for female and one for male, and also differentiated by tenure, those who are not tenured profs versus those who are tenured prof. And you could see just quickly how easy it is for you to recognize that not only that there are differences between male and female professors in terms of their teaching evaluation, the distributions are quite different, but also their distributions are different by their tenure status. Another way of looking at the same data is to put male and female teaching evaluation distributions side by side. If you were to look at advanced data mining techniques such as classification trees, you could see how teaching evaluation is different between males and females, and then after that how beauty scores or their perception of their looks by students affects their teaching evaluation scores, and this is coming right out of SPSS. Again, something that is not possible with spreadsheets.